Gary, today MTD CNC have travelled to Coventry to the home of Prima Power. Now, we're going to be taking a look into your fibre laser machines, well, your whole range of laser machines in fact. Can you give us a brief overview of the laser machines?
Okay, well, Prima Power laser machines actually developed originally from 3D laser, which is where we first started with laser technology back in the late 1970s. So, of course, we started with perhaps the more difficult end with 3D lasers, and the technology that you now found in our complete range really stems from there. Now, with 3D lasers, which we still do, obviously they go into automotive and aerospace applications, as well as subcontracts. 2D lasers, the technology has come from them. Again, they go into quite a wide range of applications. We do CO2 and we do fibre lasers, so really, again, down to the customer's requirements as to which technology is going to suit them best.
Now, in regards to Prima Power being the OEM and manufacturer and designer of their own product, I mean, can you give me an indication to the size of Prima Power before we go any further? In regards to the evolution of this machine, how many manufacturing sites, etc.?
Prima Power as a whole actually has 8 manufacturing sites around the world. It's a global company. We have got, operate in more than 80 countries. We've got 8 R&D centres as well, so it's a big concern. And we are, as I say, spread globally, and we're actually covering a lot of different industrial sectors. So really down to whatever the customer's requirements are, whether it's automotive, whether it's aerospace, HVAC, refrigeration, just about any application involving sheet steel.
I mean, because that leads me on to really my next question. I want you to tell me about the head on this machine, which is your very own, also automatic tip chain. Some of the features, the cantilever design, for example. Let's start with the head.
Right, okay, well the head is our own technology that's been developed by us and proven out over probably the more high-end Laser Genius machine, which is the next one up from the one that's stuck behind us. And the head technology has got adaptive collimator in it, which basically means that instead of the operator having to set the lenses depending on the material thickness, the machine does all that for you. So it's a sealed unit. Because it's fibre, contamination is very, very important. It's sealed, so you can't get any contamination inside the head. And as I say, adaptive collimator basically means that when the machine sets itself up for the material thickness, the operator doesn't need to worry about it.
And you still sell CO2 products as well. Can you go into that in a bit more detail and also explain the running cost savings of using fibre?
Okay, CO2 machines are really the original sort of where laser came from in terms of industrial applications, and of course that uses a different type of technology, a different wavelength as well, a lot of use of gases and mirrors and everything inside the machine. With a fibre optic technology, basically you've got a fibre source and a fibre optic cable delivering that straight to the head. So that makes it a lot less complicated. It also means that for the on-the-fly cutting, which these machines do, the fibre is travelling with the head and you've got no problems with mirrors or anything else. So a lot more easy to use, a lot more easy to set up, but also more cost effective. And because you don't have the use of gases, it also means that your running costs are a lot lower.
And also environmentally friendly, I would imagine.
Yeah, you're not using anywhere near as much gas. I mean, there are some gases being involved, but nowhere near as much gas as you would do with a CO2 type laser.
Now, with the cantilever design, some may say that this is not the correct design, that you get droop, deflection. What would you say to that?
On our machines, that's not the case. If you look at the design of the cantilever, it's extremely robust. It's designed to actually take the weight of the head, even at full extremity, and more, much more. It's almost an aerospace type design when you actually look at the way it's made. So you've got no problems whatsoever of any kind of droop or anything like that. The way it's mounted, the way it's driven, it's all designed to withstand the inertia of the drives moving across it, the very rapid movements of the machine, and you don't have any problems at all. The accuracy on our machines, both the actual individual axes and the combined axes, is superb. Likewise, the repeatability in achieving that accuracy.
Do you also get faster speeds from point to point with having the cantilever design?
We can do, yeah. I mean, because we haven't got another side being driven or moving along, it's all down to the one side of it, which basically means that the speed of it being able to move and the fact that it's not having to synchronise itself with another drive mean that we can get to a position very quickly, and more importantly, because it's servo controlled, because of the way that it's driven and the way that it's mounted, means that we can get to a specific point with incredibly high accuracy over and over and over again.
Now, we had the doors open a few moments ago, and I also noticed the accessibility with having the cantilever design is also another benefit. Is that correct?
Absolutely, yeah. The cantilever basically means that you've got one open element underneath the cantilever, which is at the front of the machine. Of course, the cantilever will park itself at one end of the machine as well, but what it means is that whilst your machine is processing, any parts that need to be removed, what you can do is when the machine has stopped processing, you can open the doors and go in and pick those parts out. Also from a maintenance point of view as well, it means it's a lot easier to get in there because the cantilever frame is not in the way.
Now, you mentioned opening the doors. Now, both doors open and the ergonomics of this machine are fabulous, really. The accessibility is excellent. Can you tell me the reasons why you've got such accessibility?
There's two reasons for that. First of all, obviously, is for the convenience of the operator and the loading and the unloading. We actually have different cabin designs. Of course, being fibre technology, you need to have a completely closed cabin around it for a safety point of view. But also, the accessibility there is good for a standalone machine such as this one. But also, if we then want to automate, we've got a design there that means that all of our automation systems can work with it, both from a loading and unloading point of view. On either end of the machine, the cabin designs are really built around the capabilities that we've got for automation, which then obviously bring the machines up to another level because there are so many different possibilities we can have from an automation point of view.
In regards to technology, automation is one of your biggest assets, if you like. I mean, again, it's your own product. The automation is your own product. So have you got the options to run these machines manually and to also automated as well?
Of course, yeah. You can either run them in a standalone format as they are now, or in a fully automatic lights out format. Even if they are set up as a fully automatic machine, they can still be run as manual machines. So perhaps for whatever reason you may have a job that comes in and the tower unit or the server unit isn't equipped with the right materials in there. It could be a last minute job which is a different type of material. There is the capability there to stop the machine, manually load, run the parts, manually unload again, and off you go again in automation. The machines are very flexible in that respect.
So how easy is it to program? You've got your own programming language and your own software, but how user-friendly is the program, and what kind of features have you got to make the machine even more efficient through the software that you offer?
Okay, on the control systems, we've got a lot of different technical suites that we can put on the machine that will optimize its processing. So, for example, we have a suite that will allow it to run lights out unattended. That actually gives it a productivity gain, but it does mean that the machine's got features and software controls on it so that if there is a problem, the machine can react to it. We also have optimization suite, which will mean that the machine doesn't what I like to call dwell time, doesn't have any dwell time issues at all. It's basically doing everything it can as soon as it can, piercing on the fly, for example, or grid cutting. They're all built within those suites. And again, it's down to configuring the machine to suit the customer, whatever their application might be.
You've got a very broad range, and we've covered the broad range today, and as you say, you know, it's all application specific, and you've got a machine or a product available to suit them applications. For people that have watched this short video and like to find out more, how should they get in touch?
The easiest way to do it is either to go to our website, www.primapower.com, or if they contact Prima Power in Coventry, we can obviously speak to them and look at their application and guide them as to what's going to be the best solution for their requirement.